Hello, students. Jumping into the assessment for 6.1. Let's take a look at homework 1 through 15, 18 to 23, and the number 26. So 1 through 15. So write a sentence that illustrates this in a division problem as part of a whole and as a ratio. So again, that's those three definitions. If you look back, you can kind of see those. And for each of the following, write a fraction to approximate the shaded portion of the whole. So again, look at these. These are usually the same size pieces. With the triangles they are, with the number line it is, with the dots it is. This one it is not. So you may want to consider breaking up to see how many total pieces there are. However, there are other ways to do that as well. Just a hint if you do get stuck on something like that. Make sure it's the same size. Don't say 2 out of 4, 5, 6, 7. It's not 2 out of 7 because there aren't 7 equal-sized pieces here. Okay. If the entire rectangle is a whole, now remember, this is talking about what is my whole object? What fraction of the entire whole piece do I have? And if you struggle with kind of seeing how does that relate back to the numbers that I have, think of creating or breaking up that whole object so that you can see things that are actually going to be roughly the same size. It might make it easier to see what fraction is there. Okay, so here they say from 0 to 1, here we go. Make 3/5 out of whatever it is. Totally your choice. Just be careful because they want them to be 3/5. You should have 5 equal-sized pieces. And so I just want to bring up here for this portion down here on the bottom. If you're trying to cut, like if it was a cake cutting from the top, that's going to be pretty challenging because then we'd have to have these circular wedge pieces to make them all the same size. Or you can think about kind of making kind of cuts this direction. So like if I cut off like the top layer of cake, okay, and I cut the next layer down, and I'm trying to do it freehand. Why am I doing it freehand? So that these would match the kind of the slices that are being made on there. So you want the curves to match as you do it. Okay. All right, so that's question 4. Let's see here, 5. Based on the visual observations. Oh, now you have to do some determination. A student comes up and says, "Hey, I shaded half of this. Look at me. I got, yeah, it's 1 out of every 2 pieces is shaded." Let's see here. Each model below represents the given fraction. Number 6 is the question I think sometimes students struggle with, is thinking this is the whole, but I want you to think differently. I want this to be the fraction, and I need you to create a shape that would represent the whole object. Okay, so this is the 3/4. It's 3/4 of the whole. You need to tell me what is the whole or unit object. What does 1 look like if this is 3/4? Okay, and there may be more than one way to do that. As a matter of fact, I know there's more than one way to do that, so totally up to you on how you do it. At least for these kind of weird geometrical shapes. For the ones where you're kind of creating whole objects with like circles, that one is not quite the same. All right, let's see here. Referring to the figure, represent each of the following quantities. Oh, okay. So the dots outside as part of all the dots. I'll let you write these. These are fractional pieces. And then we have a Venn diagram, which is great. Jumping back to chapter 2 with Venn diagrams. And you have to figure out the fractional piece. The union has what fraction of the universal set? For each of the following, write 3 equal fractions. Got to use that fluff. And then find the simplest form for each of the following fractions. Okay, again, floth, but just going backwards. Find the best expression here. So again, can I factor or floff this? Can I simplify these? Look for that distributive property. You have to have a multiple. So when it has addition in the middle, do not make that mistake, right? The dark side is luring you in, but you are going to be strong. Okay. Find the simplest form. So again, floffing, determine whether these are equal. You could do that with floffing. You could do that with the GCDs. You could do that with the creating a common denominator so that we can use the multiplication. A lot of different ways to prove whether one is equal or not. And same here. Now this one says determine whether they're equal by changing both to have the same denominator. Realize that you could floff them up or you could floff them down. Totally up to you as you're doing it. Okay. And then the last one, draw an area model to show that 2/3 is equal to 6/9. It's very similar to what I used in the video I made where you kind of create a box, then you can kind of make more cuts. The shaded piece would be exactly the same. Let's see, it was 1 for 15, then 18. 18, solve for x in each case. So again, here you could just floff. Just floff it up to get to the value you need. And again, you're solving for x. So what value of x makes this correct? And there may be sometimes where there's more than one value of x that makes something correct. Let's see here, find... Oh, replace the comma with greater than, less than, or equal to. So again, a lot of different options here, right? Totally up to you how you choose to do it. Yeah. So again, if you happen to use, if you want to use the Kool-Aid property, use the Kool-Aid property. That's totally fine too. Next one says, find two rational numbers between the given rational. Oh. I just love these problems so much because you get to use that Kool-Aid property. Or you could, let me take it back. You could use the Kool-Aid property. You don't have to. You could. It might be really quick to do that. So there you go. Fractions in more everyday life, reading a ruler, which is one of the skills in the Common Core. Students need to be able to read a ruler for measurement. Fill in the missing numbers to create a sequence with each term being less than the preceding term. So you want to make a sequence that's less than. This is not an arithmetic sequence, doesn't have to be. And use the fundamental law of fractions to show that a number can be written in, 0 can be written infinitely many ways. And let's see here, 1 through 23, that was that one. And then 20, oh, that was 24. Maybe I should have assigned that one. Let's see here, 26 is here a typical millimeter. How many millimeters would there be in 5 meters? So thinking of how to floff that up. Let's see here, then we had, there's a few different pieces. Oh, then we get into math connections. So that wraps it up for this video. And again, try that Kool-Aid property. I really think you're going to like it. So that if someone came up and said, okay, I've got 14/21, and the other person said, oh yeah, well, I've got, I don't know, 2/3, right? And you could say, okay, well, hold on. What did I add here? That's 18. What did I add here? That's 12, right? And you say 12/18. 12/18 is 2/3. Well, guess what? If 12/18 is 2/3, then these are all equal. That's what's kind of great about this property. So in any case, there's kind of a fun one, a fun way to use it. But yeah, you could do it for any two numbers. 2/7, which again is pretty close to a quarter, and then you could do 11 45ths, right? So what did I add here? I added 9 and I added 36. What is 9/36? 9/36 is 1/4. Well, this number of 2/7 is pretty close to a quarter, but 1/4 would actually be 2/8. So when I made this smaller denominator, it made this value bigger. So when I think of 9/36, 9/36 is actually going to be smaller than 2/7, and that's why 11/45 is less than 2/7. Okay. But it's not, you don't only have to do it that way, right? You could say 2/7 and 11/45 and multiply. So I could floff to get that denominator to be exactly the same. And then again, I don't even care about the denominator now that I do this. 45 times 2 is 90. 11 times 7 is 77. And I can see this one's bigger. So couple different approaches, couple different ways to do it. And hopefully that gives you a push in the right direction. All right, off you go.